Alright, hello nobody, welcome back to me not playing video games for once. I might have said this before, but I had to pre-record videos for school, and my stockpile has recently run out. So why not try out something new? I like physics, and I like animation, so let's put them together. But before I get into the video, I'd just like to say thank you so much for 10 subs. I know that's not a lot, but it really means so much to me. Next goal will be 25, so hit the red button and like the video, and hopefully we can get there. Okay, so before we get into the actual math, let's create a world because physics runs on a certain set of rules that can or cannot be broken. Let's say that this is an alternate universe where everything is the exact same, except there's no friction or air resistance. Friction and air resistance makes everything harder, so I just decided not to include them. And in this world, there's a 5-meter cliff with concrete on the ground below, mainly because I don't know how to calculate bounce with anything other than concrete. And for some reason, I am standing on that cliff with a 2012 Titleist Pro V1 golf ball. This is usually a given, but just to make sure everybody knows we are on Earth, there is gravity, we are not floating. Now, since we have established a world, let's enter the land of equations. So these are the 3 equations we need. The first one will help us find distance at a certain time. The second one will help us find the velocity of the bounce. And the third one will help us find the velocity of the bounce before it actually hits the ground. Oh, and if you didn't know, velocity is essentially the same as speed, but velocity has a direction that goes with it. We now have all the equations we need to start doing the math. To start off, we need an endpoint so we don't keep punching in numbers for eternity. We could rework the first equation into this. I got rid of VIT because initial velocity is 0, so it cancels it all out. Then we plug in the numbers, 5 for x, 9.8 for a, and we get about 1 second for our final time. Now we can plug in any time from 0 to our endpoint for t, and since I'm animating in 24 frames per second, I will use 1/24th second increments. Turning the first equation back to its original form, we can then find all the distances by plugging in the numbers. To place these points, we actually have to do a little bit of extra math. The first thing we do is get one of our points and divide it by 5, which gives us a percentage, and then we can multiply that percentage by the distance between where the ball is dropped and where the ball bounces, and then we can get how much the ball actually moves. And it will look like this. It is a little janky. My calculations are for 24 FPS, but for some reason I think I animated it in 30 FPS. I don't really know. I couldn't figure out frame rate in Premiere Pro, and I can't use Adobe Animate. So long story short, it looks bad, but the method is right. Now we have to find the final velocity by using this equation. It's very simple, so I'll talk quickly. A equals 9.8, t equals 1, and bada bing, bada boom, we have our final velocity. Next, we again do a simple plug-in and do math equation. Plug in 0.7 for e because according to Google, a golf ball has an e or coefficient of restitution of about 0.7, and initial velocity as 9.8, and bam, 6.8 as our bounce velocity. Then we use the first 2 equations again. But we have an initial velocity, so in the first equation it will be plugged in here, and the t next to it will be the same number as the t on the other side of the equation. For the second equation, we plug it in here instead of plugging it on the other side of the equal sign, which is the final velocity spot. The way down is luckily the exact same as the way up, so we can just remap the points just going down. And now we can repeat this until the ball is still. Technically, in this alternate universe, it's never still, but I won't get into semantics. But just dropping a ball is a little bit boring, so what happens if we throw a ball forward? Just straight forward, not up at an angle because school is entering finals weeks and I don't have the brain power to edit another 2 minutes. Okay, so if we threw a ball straight forward, it would go down at the exact same rate. This is because gravity acts the same amount on any object, so if our initial velocity in the y direction, which is up and down, is the same, then it would follow the same path. And since there is no friction or air resistance in this universe, if you throw a ball forward, it will keep going that same speed no matter what. So if we have a velocity of about, say, 0.5 meters per second, the ball will keep going 0.5 meters per second forever. So if we remap the points going down and have a consistent 0.5 meters per second, then we have an animation for a ball being thrown forward. Alright, so after a long time, this is what a ball being dropped and a ball being thrown would look like if it was animated using physics. Alright, so we did it. And it is nice to have a sense of reality in cartoons, but it's also much cooler to have the world be crazy and not make sense. So essentially I did this because I could and I thought it would be fun. Hopefully this is a little bit educational and not a waste of time. I'm sorry about the weird upload schedule. Again, school is getting really tough and I wanted to make sure this video was high quality, so I'm sorry for the 3 weeks. Anyways, Thank you, nobody, for watching, and I'll see you in the next video.